Okay, folks, this is Schetz, and in today's lesson, we're going to be finding out what kinds of roots we could possibly have. Are we going to have positive roots? Are we going to have negative roots? Or are we going to have any imaginary roots? So let's take a look at this. When we set this equal to a 0, we're going to add a 2, and a 2 is, f of 2 is a 0. It is a root. It is an x-intercept. All right, in our next problem here, that's a quadratic, so we always look for factors. We factor out an x, and we get an x plus 3. So from this one, we're going to get a 0, and there it is right there. And from here, we're going to get a negative 3. There it is right there. And our y value is a 0. There's my x. There's my y. There's my x. There's my y. So they're going to be our x-intercepts. And notice the solutions can be either real or imaginary. And real solutions, it'll cross nicely or in a weird spot, the x-axis. And then for this sentence here, the nth degree, well, our highest degree is a 5, so at most, it's going to have 5 real zeros. All right, so let me scroll down here. And factoring still provides a key. If it's a higher polynomial, you'll want to use synthetic division. There are also other aids that are going to help us with the type of zeros, and that is Descartes' rule of signs. So let me just show you how this works. What we're doing is looking for the variation in the sign, the change in the sign. Like, here's a positive starting out, then we change to a negative. So there's going to be one, I call it a hump. And now, if we're at negative and we go to a positive, there's a second hump, and then we stay positive. So notice this has two variations. Positive to negative is 1. Negative to positive is 2. 2 humps, 2 variations. All right, we go down to here. We start at positive. We go to a negative. There's only one variation. We stay negative, so it has one hump, one variation. This third example, excuse me, we have a positive, we stay positive, we stay positive, we stay positive. There are no variations. So that's just to get you into the idea of how many sign changes there are, or sign variations. This had 2, this had 1, this had 0 variations. Okay, over on to the next page. I'll get to this box right here in a minute. Let's scroll down a little bit here, though. So let's check this out. And here we are at a positive. We go to a negative. There's one change. Back to a positive. There's another change. And then back to a negative. So there's 3 sign variations. And when you do this on the original problem, then that's going to be this box right here. How many positive roots there are? Could possibly be 3 variations. So this number becomes a 3. All right, before we go on to the next step, let's just take a quick peek back here. If I plug in a 1, let's start that again. If I let x equal a 1 here, and plug it in, 1 squared, still 1, 1 cubed is 1, 1 to the 4th is 1, 1 to the 5th is 1. Great. On this one, let's plug in a negative 1. So we get a negative 1 here. Negative 1 squared is positive 1. Negative 1 cubed would be negative 1. Negative 1 to the 4th would be positive 1. Negative 1 to the 5th would be negative 1. So if I compare these two columns, if I take a look at this column here, what happened notice in this over here, just the odd ones changed. So I need you to remember that. From this column to that column, only the odd powers changed. Okay. So we go back to our paper. And now I want to look at this box right here. So we got the blue box by doing it on the original. Now what I'm going to do is throw in a -1, and notice what we just said the last time. Only the odd powers get changed if we looked at those last two columns. So this guy's going to stay, this guy's going to change to a negative. This guy stays -5. Here's an odd one, a power of 1. That gets changed to a negative, and then there's my 4. So only change the odd exponents. Keep these the same. It's kind of like you're plugging in a -1. All right, so negative, 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 negative. There are no humps there, no variations. That's how we get this pink box there. Great. And what's our total? Our maximum total right here will be 3 possible roots. Well, when I add this across, don't I get a 3? That leaves no room for imaginary numbers. Now, let's get back to the box above here. You know that imaginaries always come in pairs, because in the quadratic formula, you always have a plus or minus. And it could be a plus or minus 2i root 3, or plus or minus I root 7. So, in that case, we always take 2 away if we can. So for the blue one, the positive roots, 3 minus 2 would leave us a 1. I can't take 2 away from the negative roots. That'll stay a 0. Well, wait, where did these 2 go? Oh, they must have gone over into imaginaries. And notice when we total this across, we still get a 3. So this is giving us the types of roots that we might get. We could have 3 positives, no negative roots, and no imaginaries, or we could only have 1 positive, 0 negative roots, and then 2 of them could be imaginary. So it will be one of these 2. We just don't know yet because we haven't graphed it. All right, let's scroll down to the next problem. And again, I'm going to do this first positive roots to the right of the y-axis. If it was graphed, where would it cross the x? And that's what we're going to do now, is figure out how many possibilities. So we know this has a grand total of 4. Positive to positive, that stays the same. To a negative, there's 1 change, 1 hump, negative and negative. So there's 1 variation right there. Okay, now for our next negative roots, anything that would cross the x-axis to the left of the y-axis would be negative roots. We only change those that have a negative exponent. This guy's going to get changed, and this guy's going to get changed because that is a power of a 1. Odd exponents get changed sign. So this 2 stays a 2. This positive 7 we have to change because it's like throwing in a -1 right here, and we get a negative right there. -4 stays because it's an even exponent. The -27 gets changed to a positive 27 right there. And then constants stay constants. All right, so let's see how many humps we have. Positive to negative, there's 1. stayed negative. Negative to positive is 2. Back to a negative, there's 3 variations. That's going to be a 3 right there. That leaves us no room for imaginaries, and we get a grand total of 4. Now remember, imaginaries can come in pairs, so in our box above, way up there at the top of the page, we always have to say to ourselves, can you take 2 away? Well, I can't take 2 away from 1, so that's going to remain a 1. I can take 2 away from 3. 3 minus 2 is 1. Okay, well wait, where did those 2 go? They could have gone into imaginaries, and notice when we add straight across, we get a grand total of 4. So there you go, folks. If we graph this, we're definitely going to have 1 positive root. We could have 3 negatives, or only 1. We could have 0 imaginaries or 2 imaginaries. So that's what we're doing in today's lesson. It's just seeing the kinds of roots that we are going to get.